Aloha, Rich Alverson here. This is ITS 388AL, and today I'm going to go over Lab 8.8, which is find the maximum in an array. So if I share my screen, this is the lab. And so given an array of a specific number of integers, write a program that finds the biggest one and store that biggest one in T2. Assume T0 has the location of the array, and that T1 has the number of elements in the array, the number of integers. So for example, if T0 had the value 4,000 and T1 had the value 5, then that means there would be an array starting at 4,000 with 5 elements, 1, 2, 3, 4, 5. And in this particular example, after the program executes, we should see 9 in register T2 because 9 is the biggest one. All right. So I'm going to start out here, and I'm just going to put they don't want you to initialize any register or memory values in the program. They want you to initialize it out here, and that's so when they test it, they can put in values that they want. But let's do the example up above. It would be what is it? 4,000? 4,000 in T0. Oh, what am I doing? T0, and there would be 4,000. That's an address, 4,000. We want to see that address. And we want to see 4,004 because that's going to be the second number. And we're going to see 4,008 because that's going to be the third number, right? Yeah, 8, okay. 4,012 and 4,016. And let's just make 4,020. Okay. And so T1 is going to have how many there are. And there's going to be 1, 2, 3, 4, 5, 6. Ours is going to have 6. And so when this thing is done executing, T2 is going to contain whatever this is. Okay, so let's just start out by 6, 4, 20, 10, 17, I don't know, 5. All right, so just to put some comments in here, first of all, I'm going to make T0 the address of array, and T1 is size of array, and I'm going to use T1 also to decrement down through the array. That's going to be a counter, and decrementing counter, and you'll see what I mean by that if you don't know. And T2 is will contain biggest number in array. Okay, so first of all, I want to so I'm going to start by just putting this number into here, saying that's the biggest number. And then I'm going to go down the line, and if I find a bigger one, I'm going to replace this number with the bigger one. And so I'm going to keep on going down the line. If ever I find a bigger one, I'm going to put that bigger one here. And if I go to the next one, it's not bigger, then the old bigger one stays. So this one's always going to have the biggest one in it. And when I'm all done, then this one will have the biggest one in it. So to initialize this, I'm going to load Word. I'm going to load right into T2 the first value in the array. Okay. And then I'm going to decrement the counter, our number counter, array counter, by 1. Okay, so take this number, what's in there, add this to it, which subtracts 1 from it, and store that back into here. So after this instruction executes, this will go down to 5. Okay, and then I want to increment this so it's looking at the next one. Okay, so to do that, I'm going to go ADDI T0, which is this, and I'm going to add 4 to it. So that's going to equal T0 plus 4. So now this one will point to the next array element to look at. And what I'm going to do now is I'm going to check I'm going to check to see if we have reached the end yet. So it could have been that when I decremented this down, then this is going to go from 1 to 0. And if that happens, then we're done. So I'm going to put that check right here. If T1 is 0, then jump to the end. I'm going to call it end. Otherwise, load into T3. I'm going to use T3 as a temporary register. Load into T3. Load into T3. This value, the value that's pointed to by T0. In other words, T0 is now, this is going to have 4004. It's going to be pointing to this. Take this number and put it in here. And then I want to check to see if this number is bigger than this number. So to do that, I'm going to use the SLT instruction. Wait, what? SLT. Set on less than. Set on less than. What that does is if the number in here is less than the number in here, then this is going to be a 1 in there. If the contents of this register is not less than the contents of this register, in other words, if it's greater than or equal to, then a 0 is going to be put here. See, this is write a 1 in the first one, write a 1 here if the value held in the second one is less than the value held in the third one. If this is less than this, then write a 1 here. Otherwise, put a 0 here. Okay, so we're going to use that instruction, and we're going to check to see if we're going to set if less than, and we're going to put that into T4. I'm going to use T4, another temporary register, T4. Put into T4 a 1 if 0 is less than, no, I'm sorry, if T2 is less than T3. Okay, if this is the new temporary one, this is what we're storing the biggest one in. If this one, no, if this is less than this, then we want this one to be the new biggest one. So if If T2 is less than T3, then this is going to be a 1. And then we want to okay, so if T4 is 0, then that means T2 is not less than T3. That means T2 is still the biggest one. So we do BEQ if T4 is equal to 0, then skip over the next instruction. And what's the next instruction? The next instruction is move into T2, T3. And plus 0. Otherwise, skip to L1, which is jump up to L0. And L0 is where we right here, where we increment, where we decrement T1, decrement the counter, and increment the address. Okay, so let's space this out a little bit so it looks better. And that can be like that. And then we have to say what this is. And this is the end of the program. So we can just put that down here. Okay, so this loads the address of the array. No, this loads the first load first integer into T2. Okay, and then this decrements count array counter, right? What can we call it? And this increments to the next address, next array address. And then this checks done. And if we are done, we jump to end. Otherwise, we get a next array element into T3. And this checks if T2, if new is greater than biggest and than current biggest, and if the new one is bigger, or if the new one is not bigger, then it skips over to here. You can actually skip back up to here. You could, because you're going to skip this. Hmm. Yeah, is that right? That might be better. Wait a minute, I don't think this is right. Well, anyway, let's see if this works. We have 4,006, and let's enter the simulation and step through this. Okay, well, that's the counter. 4,004, get 4,004, stick it in T3. 4,004 goes in T3. not bigger. I'm just going to run this. T2 has 6 in it still. Now it's going to have 20 in it because the 20 is bigger than the 6. And that's why that's a 1. And then it's going to look at the 10 is not going to be bigger. 17 is not going to be bigger, and 5 is not going to be bigger. 17 is not bigger than 20. And when this goes down to 0, it ends up jumping to the end. Right here. Yeah, this is not very efficient. You can make this more efficient. But anyway, let's see see if I get the points for all this. Huh. All right. Well, that wasn't the most efficient implementation, but hope this helps. Thanks for watching.